In this video, I'm going to show you how you can make a simple handwriting recognition app using Python and Flask and Tensorflow. Here's just a quick demo. It asks you to write uppercase K, and we write a K, it will tell us correct, next question, and then you can write different letters and it will make a prediction based on what you wrote. And it's kind of like a little quiz game where you practice writing the uppercase version of these letters. There's also the option right here where we can add data to the data set that trains this model. All right, so let's get started. First thing we are going to do is just make a folder for this project. So I'm just going to call this alphabet quiz. And we'll go into that folder. This is optional if you would like to do, but I'm going to make a virtual environment for everything. So I'm going to do that with the venv module, and I'll just call this env. And once that's created, I'm going to start it. And then activate. All right, so now that we are in our virtual environment and in this new folder, I am first just going to start by installing Flask. We're going to come back and install some more modules, but Flask is what we need to start with to kind of get our framework or the skeleton for the app built out. So now that that's installed, we can actually open up VS Code, which is where we are going to build everything out. And I'm going to make kind of a main file. I'll just call this app.py. I'll increase the font a little bit so it's easier to see. So we're just going to make just a very basic Flask app just to make sure the installation worked. So from lowercase Flask, import uppercase Flask, and make an app. And if name is main, then we will run the app and we'll do this optional debug equals true. The one thing we're missing here, obviously, is the path or the route. So let's just do a route for that index page, that just /. So we'll just make this function called index, and we are just going to return a string. Oops, sorry, must have some shortcut. Hit some return some string. Hello Flask. Okay, so this will just kind of make sure that we have this working. I'm just going to run Python app.py and control click that link. This will open my browser with that string that we are returning. So Flask is working, which is a good sign. Now we can get into a little more complicated stuff. So basically our app is going to have this kind of main page, kind of like the landing page or main menu. Then we're also going to have pages for where users can add data, where they can draw different letters that add to the data set that we can train the model off of. And then we'll also have one, which we'll just call practice, where you can actually use the predictive model, where it can kind of give you a quiz almost. We'll say, draw this letter, and you can draw it, and it will predict whether it was the letter it intended you to draw, and kind of give you like a yes or no, like a right or wrong kind of response. For each of these routes, we're going to need a get and a post. So the get will be to load the page. So in this add data example, first we'll load the page, and then the post will be when they actually submit the the new data point. So if it says, draw the letter A, they draw it, then they have to post that data back to the server. Same will go with the practice. We're going to make a get and post for both of these. So let's just start that. We'll do app route, add data. methods equal get, and I'll just call this add data get. And then we'll just do, I'm just going to do a blank string for now, just so we can build this out. So this will be similar, except it's going to be post. We're also going to change this function name. And then I'm going to copy both of these, because now this add data is going to be practice. That's that other route. And then instead of add data get and post, this will be practice get and practice post. Okay, I'm going to get rid of those little notes. So we have, the two different routes, or two different groups of routes, and get and a post for each. So you'll probably notice that we're not going to really get anywhere by returning strings. We actually need to return HTML files. So that can be like our next step. So rather than return a string, we're going to return a render template. You can see this kind of auto-completed for me. I'm actually just going to import it straight from Flask. So from Flask, import uppercase Flask and this render template function. And this function, you just give it a name of an HTML file. So we'll do index.html. So we need to actually make this index.html file. And before we do that, we need to make a folder called templates. This is where Flask by default looks for these HTML files. And again, we're just going to do a quick test. So I'm going to say hello from index.html. So when we, what we expect this to happen is once we go to this route, it'll render this index.html file. Sometimes the server will stop as you're writing because it tries to refresh and there's a bug in the code. So just restart it if it died. Go back to your browser and look at that. Hello from index.html. Perfect. So we're going to want to add some more complicated stuff here. Before we do, we actually want to set up some inheritance. So we can make this base.html file, which has some like the header tags and some of the other like CSS links and JavaScript links that all our pages will share. And then this index.html page and our other pages can all share the basic content from here. And so writing out HTML is going to be pretty boring. So I'm actually just going to kind of copy and paste this in, and then maybe we'll go over it and kind of point out the key features. And of course, this will be on the GitHub, so you can just grab it there. But for my base file, this is what it'll look like. You can see just the basic head. We have a title. We have some style sheets and some JavaScript that we'll talk about later. Most importantly, there's this inside the body, we have this block named content, and then there's an end block. So it's like an empty block. This is where we're going to put in, once we inherit from the index, or sorry, when index inherits from the base.html, this is where we're going to put in that like data specific to the index.html page. So let me copy in this one. Again, it's just kind of boring to do this. So I know sometimes people don't like copying and pasting, but I think it'll be a lot quicker that way. So just quick note, we extend from base.html. We're inserting all this stuff into the block named content. You can see we have these buttons. There's going to be a button for the practice, button for the add data route. You want to make sure these match the routes in the app.py because that's where the HTML is going to send those requests. And then and just some random divs and stuff for styling. So at this time, let's also make the practice.html page. All right, so this one has a similar extend, also going into that content. We have a title, we have this canvas. This is going to be that kind of drawing area where we draw the letters. And then we have some buttons. They're not connected to anything just yet. We don't have JavaScript written yet. but we'll have like this practice action where you can like check your answer, and then a reset canvas to, if you make any mistakes, you can clear it. So let's make, next one would be, we'll just call it add data.html. And for the most part, this is actually pretty similar to practice.html, so we're not going to go into any details here. While we're here, though, messing around with HTML, I'm also going to add in an error page. This is good to have in case we run into any issues in the server. We can send it to this error page, which obviously isn't very helpful. It just says something went wrong. But we'll just throw that together real quick. So next, let's just add some styling. In the base.html, you can see that we're actually pulling from this Bulma CSS library. We're just using the CDN, so we don't have to worry about downloading it and putting in the right file, even though that's pretty easy to do. But then we also have this index.css file that we'll do our custom styles in. And kind of this craziness here, this is some Flask tricks for connecting to these static files. So you can see we're saying we're going to have a folder named static, and inside that folder we'll have this file name. So let's make that folder static, and then I'm going to make those files index, .css. And once again, writing CSS would be very boring, so I'm just going to copy and paste. So now we have some basic styling stuff. So this is a good point to take a break and check out how things look, and it looks like our server's still running. So I'm just going to go up here and refresh this. Awesome. Okay, so we have, this is our index page. I'll zoom in just a tiny bit. We have our practice button, our add data button. This takes us, or this should take us to our practice page. What happened here? Looks like we had an issue. Oh, I remember. We didn't finish these routes. So in our routes, we were just returning blank strings. So let's actually return templates. And this will be a little more complicated logic here, obviously, once we get moving to the trickier stuff. But for now, we'll just return the same thing for the get and the post. That returns the practice page. Well, good thing we checked, because I kind of forgot about that step. Okay, so let me restart the server because it looked like it died. And now we'll restart, go to our practice page, and great, we have our little drawing area. Doesn't work yet because we haven't added the CSS yet. Return to main menu takes us back here, add data. Again, we have this area that's not working just yet. As for the CSS, it's pretty good though. We might add some changes later on, but for now, that's in a pretty good place. So the next point, or next part, is the JavaScript. So again, we're actually taking the CDN for jQuery just to simplify things, and then we'll have a custom file that's index.js where we'll have the logic for the little drawing area. So let's add that in that static folder, index.js. And once again, I'm going to copy and paste this in. Part of the reason I'm doing that is I actually took a lot of this from this article where someone explained a really good way how to make a simple drawing app. And in this article, they actually made it a lot fancier. I took the bare bones of it just for this little project. I also have a link to a Stack Overflow question that helped me figure out how to make this work for like touch and mobile. So we'll go over just the basics real quick. Essentially, we have the start canvas function where we get the canvas, the little drawing area, initialized. We kind of set up the settings. So here's what you can play with if you want to change the color or like the width. Then we have these event listeners. So I'm going to scroll down to these ones. And this is where we're actually using the jQuery just to simplify some of these event listeners. But basically we have a mouse down, a mouse move, mouse up, and mouse leave. So when mouse is down, we set paint to be true. And when paint's true, we're going to keep a track, or kind of keep track of the clicks. And when the mouse is moving and we're painting, if we're just moving and not clicking, that's no good. So that's why after we click, mouse is down, then we move, we'll start to paint, which is done by adding these clicks. And then each time we do that, we draw the canvas. So for adding the clicks, we're basically pushing just the X and the Y coordinate of where the mouse is into a big array, as well as a true or false of whether we're actually moving it. And then in the draw canvas function, we just iterate through those click X and click Y arrays and put those onto the canvas. The other functions to note are the clear canvas, which is pretty straightforward, and the reset canvas, which not only clears the canvas, but resets those arrays. All right, so here's kind of where the code for the drawing area kind of ends. And then we get into some of the logic for actually moving the data from that drawing area to our server. So we have this function called getPixels, which takes, we have that context, and we get the get image data for the, the whole area. And what we're going to do right here, the pixels actually kind of show up like this, where we have 4 numbers, and that is actually for 1 pixel. 1 pixel is represented by 4 numbers, all in one array. We actually only need 1 of those, just because we're doing like a black and white thing. So we just need 1 to represent like whether it's a, a white, gray, or black. So in this loop right here, we're just grabbing like every 4th pixel. And so that brings us down to, let's see, I'm really bad at math. So whatever 200 times 200 would be, that brings us down to a list of about 40,000 pixels. But having a bunch of training data by 200 by 200, that's essentially like a data set with 40,000 columns. That's quite a lot. So we actually want to shrink this down. So what we are doing in this little project is going from a 200 by 200 to a 50 by 50. And the way we do this is kind of, it's a little crazy. There probably is a better way to do it. But essentially, this is kind of a quick way to compress this image while going from 200 by 200 to 50 by 50 while still keeping like the main shape that's found in the data. And so this is actually like kind of a weird process. So I made a spreadsheet kind of visualization of how this works. So say if we had this image, this is 24 by 24 pixels. Each of these pixels are between 0 and 1, where 1 is black and 0 is white. If we were to condense this 24 by 24 into a 12 by 12, what we would do is on like the 0, 2, and 4, so every other row, we grab every other pixel. So we do every other pixel, but then we skip a row, and then every other pixel and skip a row. And then if we take all these pixels highlighted in red and transform them right here, you can see this is a 12 by 12. It still has the same basic shape as this 24 by 24. So, you can say these are the same images, representing the same thing, which means when we are drawing our letters on a 200 by 200, we're going to do the same thing, except instead of skipping every 2 or skipping every 1, we're going to do this for every 4th pixel, because we're going by, we need to like scale this down by 4. So what that looks like here, maybe not the best way to do this again, and like it's not very dynamic, but this outer loop iterates by 800 every time. So 200 times 4 is 800. So this handles, skipping every 4 rows. And then we have this plus equals 4 right here. This is handling skipping every 4th pixel as we go across that row. And so essentially where this underscore pixels grabs every 4th pixel, so we get it into the list of 40,000 pixels. And then this pixels without the underscore, this is actually the compressed array. So we would expect this new pixels to be 50 times 50, so 2,500 pixels long, like that array. So we can actually test this out because the way we have it set up right here is we're going to call this getPixels action or this function in these actions. All we're doing right now is we're just going to grab the pixels and then just print them out. And then just to make sure that we're all good, let's go, we'll start at the add data page. Right now, the add data page on click does add data action, which is going to go to this index.js file. And so one quick thing before we forget, you'll notice, you'll remember we have this start canvas function. We don't actually call this anywhere yet, which is an issue because in practice.html, we need to like initialize the whole canvas. So we need to call that here. And so I'm just going to put a script tag and then do some jQuery to say document. When the document is ready, we're going to call this function, which will be the start canvas function. And we need this in the add data as well. So I'm just going to grab that. Great. All right, so now we should be ready to give this a go. And let's hope everything works as expected. And I have to restart my server, go back to the browser, and let's go, we'll just go to add data, even though they're the same right now. So I'm going to open up the console, and I'm just going to draw the letter A. And so perfect, this is what we expected. Use of the getPixels function to grab that data. It compresses it down to 50 by 50, which is an array of 2,500 little pixels. For the most part, these are all going to be 0 because 0 is white. We can test this out again. I'm going to hit clear, and I'm going to drop in this corner because this is like where the array starts. And once you do add data, perfect. Yeah, you can see we have, these are the first 3 are black, and this one's kind of gray because it's kind of on the edge. It's kind of hard to get a mix, but you can see the more you draw over there, those first values are going to be dark. Now that that's working, I'm just going to really quick check that the practice is working the same, draw a little doodle. And great, this one's working as well. All right, so the next part of this is actually starting to track this data. So kind of the steps we're going to work through is build out this add data function or functions so that we can start to capture the data. And once we get enough data captured, then we're going to make the machine learning model, and then we will apply it in this practice function. All right, so let's get started with that. Kind of the first step in this add data.get, like I said, this is when we load the page. So we're going to need to kind of send a prompt to the page. So like the page would be like, like draw a B, I'll put quotes around this, so like draw an uppercase B, so that the user knows what to draw so that it can come back to the system. And then in our file, we'll have, this is a B, and then, a whole bunch of pixels associated with that picture, right? And so just kind of a reminder of the terminology, this B, or this file that's going to contain all those letters, will be the labels. And then we can call this the other stuff kind of whatever we want, but like the images or the pixels or something like that. And before we get too ahead of ourselves with that, it's also important to remember that this machine learning model isn't going to be able to just say B. It will, but how it's going to do that is actually associate a number with B and with every other letter in the alphabet, and then predict a letter. So it makes sense to say if it predicts 2 means B, or if it predicts 4 means the letter D. So we're actually going to set that up right now. And I found one way that I like to do this is using a library called BiDict, which is a bidirectional dictionary. So this is how it's spelled. I don't have it installed yet. I just wanted to write it out first. So let's open up this and let's install ByDict. So if you remember, just a normal dictionary in Python goes keys to values. This ByDict is the same, except you can also reverse it and go from your values to your keys. So now that we have this ByDict installed, we're not getting that error. So we're going to make like an object that has kind of this mapping for each number, or sorry, for each letter to a different number. And we're actually going to do this just in the shell. It'll be a little easier. And it's always fun to use Python during your Python projects. And so I'm just going to first import this ASCII lowercase, or no, sorry, uppercase, which if you've never used that before, this just has, it's just a big string with all the uppercase letters. And then we will do, like, each letter will be mapped to I+1 for I and letter in, we'll just enumerate through this ASCII uppercase. And then just like that, we have an A to 1, B to 2, and so on, which is what we wanted. And that saves us from typing that out, which is nice. So I'm going to put this here. I'm going to call this the encoder because it's basically encoding that information, you know, A to 1, B to 2, and so on. And then I'm going to have to clean up the spaces real quick. Okay, and then this is just a normal dictionary, so that's not exactly what we want. We're going to just wrap this in ByDict, because this ByDict object, you can just pass in, you know, normal dictionary to make a ByDict object. Great, so we'll start using this now, not use like the full capabilities of the ByDict just yet, but it's a good start, so might as well just do it right the first time. So now that we have this list, specifically these keys in the ByDict, our list of possible letters, we want to pass one of these letters. Remember, the whole goal is to send a prompt to this page. So let's do that. Let's just kind of do a random one. There's a couple different ways to do it. We're just going to say letter is going to be, and let's actually import this. Import that choice function. It's a very easy function to use. And we actually need to convert this encoder.keys into a list first, because I think its default type is like a dictionary keys object, which doesn't work well. So we have encoder keys, which again, this is A, B, C, D. Convert that to a list, and then just grab a random one. And so now that we have the letter, we need to pass this to the adddata.html page, which you can do by just using these keyword arguments. So letter equals letter, where this left one will be what the parameter is named on the page, and this right one is the actual value. So if this was called D, you know, then we'd have to change this to D, like that. We'll just do letter, makes more sense. So now on the add data page, we need to display the letter that we want the user to draw. And I'm just going to add a new div for that, just so it has a place to go. And we will just put in the paragraph tag, and we're going to say write in uppercase, do quotes. And so now we're going to do these open and close double curly braces. And this is Flask syntax for using those variables. So I'm just going to do letter, and this is Python, so we can still use Python functions. So I want this to be a lowercase, because we're quizzing them on writing the uppercase version of it. So it's got to be in lowercase for it to make sense. So this will display the letter we pass on this page that we send from the server. So let's test that, because that's probably a good place to test. Need to X out of that. start the server. And this is all happening on the add data page. And look at that, write in uppercase R, in which case we would write in uppercase R and nothing would happen, right? It's just going to print it out to the console, which that can be our next step. So let me go back. So we're going to come back to this and add some changes, but for now, that's good enough for the Git. Let's focus on this post. And so the issue is we have this index.js where we, right here, we get the pixels and we're just printing them out right now because we don't know what to do with them yet. Somehow we need to send these pixels to this function in this app.py. We have this path built out. We have it set to accept a post. We just need to send that from the JavaScript. And I think there's a couple different ways to do it, which is very common with these kind of programming challenges. But what I decided to do was just use a form. Forms naturally are kind of built for posting data to a server. So it seemed like a pretty simple choice. And we'll get into that right now because that's kind of what's holding us up. So we don't have this form just yet. We have these buttons, and I might just put this in the same div right here. And I'm going to make a new form called add data form. And the action is going to be add data. Make sure you spell that the same as how you have in your Python file, and specify that this is going to be a post. Great. So I'm going to keep those buttons inside the form, although it might not matter if they are or not. And then, so you might be asking, well, how are we going to get this pixel data into this form? So this might be a little bit hacky, but I think it will work just fine. We're going to make two inputs, one for the pixels, and this will just be called pixels with the ID pixels. And we'll give it this type of hidden, which means it's not going to show up on the page, but within that HTML, there will be part of the form for these pixels and for this next field we're going to add, which is the letter. So once we send in this get, we're going to send the letter, but in the post, we want to return, no, we're expecting to get the letter and the pixels. So that's why we're adding the letter input as well, which will also be hidden. But we can just set the value of this form or this form input just to be the letter, because once we send up this letter, we can kind of pre-generate this input to have the letter already as value. So we can just grab it back. It just makes it a little simpler rather than passing that letter around in the session, which is something we'll get to in a bit as well. But now that we have that form built, we can go into this index.js. And in this function, now that we have our pixels, what we need to do is get the element by ID, grab that pixels input, and set its value to the pixels we just got from that pixels function. And now that that's all squared away, we can do get element by ID, grab that form, and then submit it. Usually the submitting is done like with a button, but let me fix that autocorrect. But we can submit it manually through the JavaScript. So when they hit the button, we grab the pixel, put that pixels in the form, and then submit this form. So now this form should show up here on the server, right? But to grab the data from the form in this Python, in this Flask server, we actually need to add another import called request, spelled just like that, I think. Yeah. So this request object is passed. It's kind of like automatically passed in for these posts, but just bringing it in allows us to access the data. So let's just start out by doing print request.form. So that form object is kind of thrown into that request for these posts. So let's give that a try. So I'm just going to start back over here. Looks like my server died. Oops. All right, so add data. So it says write in uppercase D, which I'm not really good at drawing with my mouse, but we're going to add data. And look at that, we've got an error, letters undefined. Oh, so what happened, let's see. Okay, so if we go, so I'm just here in the server log. This is the form data. So it comes in as like a dictionary with the key being pixels. And here's all our pixels, which you can see some variation, so that's good. And then we also have letter is D. So that's good. It actually worked. The issue, I think, is what happened is we're trying to render this template, but this time when we render the template, we're not passing it the letter like we did up here. So this brings up a good point that we can just fix real quick. And I'm actually going to import some more things from Flask. And I'm just going to reorder those. And I'm going to expand this because we're going to be importing some more stuff. So we'll clean it up a little bit. We're going to import a redirect and URL4. And so once we get the post for this add data, we're going to kind of do some more logic and stuff right here, handling that data. But once we're done, we just want to redirect to the GET. We just want to create a new GET request so that the user can get a new letter to draw. And this is URL4. So for this function, right, it'll redirect to this URL. So let's give that a try. It's a good place to test it out. Restart the server. And add data, draw an H, and perfect. So if we go back to the server, you can see we got this big thing of data, all the pixels, and the letter was H. And now we got a new letter to draw, so that we can go on kind of for a while like this, which is good. We're really on a good track. The next step, as you might guess, is actually to do something with this rather than print it out. So let's do that. Let's grab the label first. And so remember, this form is just a dictionary, so we can just grab it with the key. And then the pixels are going to be similar pixels. The letter is pretty easy. It's just a single character. But the pixels, as you probably saw in that log, were a big string of numbers. So we're going to do split on that comma, which will now give us an array. And just to make sure, you never know when you're splitting arrays and stuff, let's just print out the length of the pixels. We can also print out the label. Let's give that a try. Restart the server. Okay, draw an S and draw V. Perfect. Okay, so we got an S with 2,500 pixels and the V with the same. So that's looking really good. Before we kind of get working on kind of the next part of it, I do want to add a little change to this UI. When it says draw an I, you draw it, but there's not a lot of feedback. Like you would assume that, your request went through and that the letter I was added to the data set. But we should add a little message that kind of pops up to say, this worked as expected. So we're going to do that actually by using this session object that comes with Flask. And you'll probably see why in a bit, why we like to use it. But here in this get, we're going to make a new variable just called message, which kind of has, that message that says like, the letter K has been updated in the data set or something like that. So we're going to do, so session is basically a dictionary as well with keys and variables. And by using this get, we can handle the case where when we first go to this page, there's not going to be a message, because we haven't done any data yet. So this get will try to grab the message or the value associated with the message key, or just a blank string if this message variable doesn't exist in the, this session dictionary. And you'll see how that works in just a second. But just like that letter, we'll just pass the message to that add data page. And then here in add data, if this page was being loaded for the first time, or coming to this add data page and there is no message, it'll be a blank string. So we're actually going to do an if statement. So if message, and we can just do that alone because if message is blank, that's going to equal false because there's like no value there. So if there is a message, then we'll just display that. Just like that. And then we need to close this if with the end if, which again, this is like a mix of like kind of like Flask and Python. Cool, so this will get that message, which is good. Now we actually need to, set the value for that message. So down here in the add data, after, this is kind of a stand-in for processing the data, which we'll get to in a bit, we can say session, and remember this is just like a dictionary, session message is, and I'm just going to use these Python F strings. They make formatting a lot easier. So the label or the letter, so was added to the training data set. So now this will put that, so we're using the session just so we don't have to communicate between these two. Just because we're using this redirect, it gets a little tricky to send variables from this function over to this one. So that's what the session is nice for. So let's test that out. And I bet my server died, so I'm just going to go ahead and start it here. All right, so draw an uppercase T. Oh, so this is interesting, which I forgot to add. So the session is unavailable because no secret key was set. This is just this is just a security issue that we can take care of really quick by just doing app.secret key. And I'm just going to call this alphabet quiz. If this was like a real project, you'd want to be, actually do something more smart here for your secret key. But that should fix our issue. And actually, just while we're here, we'll run into this issue if we don't fix it now. But once we go to the page, we want to clear the session, or else if we go back to the home page and then back to the add data page, it would still show that message of like the last letter updated. So I'm just going to clear that dictionary right there. We'd find that bug at some point, but I'll just get it done with. Okay, so now we draw the F. And then perfect. F was added to the training data set. Now write uppercase H. Okay, so that works good. I don't really like how it looks though, so I'm just going to add quick styling, which I'm actually just going to add it right here in the HTML file because I'm being a little lazy right now. So let's just start by getting it just as overall div, just like a little padding from the whole, like the drawing area. And then I don't want this to be too big, kind of like take away from the actual question. So let's get like 0.75. And I'm not a master at CSS. If I'm doing something weird, just apologies for that. I'm also going to give that a little margin from that message up above. Okay, so now write a V. Okay, that's better. It's like a little smaller. It's not as distracting. Uppercase S. Okay, awesome. All right, so this next part is where it really gets a little messy because we have to start capturing the data. But to do that, we have to kind of do it once for one data point and then kind of change the way we do it so we can capture the subsequent data. And again, this disclaimer that this might not be the best way to do it, but I decided to save the data in just pickled NumPy objects. You know, there might be a better way to do this, but I think this works well enough. So we're actually going to get started with that part. And before we start off, let's make a folder called data, which all the data will go into. And then let's install NumPy. So I'm going to kill the server, pip install NumPy. So what we're going to do, so we have this label, we have these pixels, we want these to be saved. We're going to save them in individual files, just to kind of keep things straight. So once we have this label, we are going to, and like I said, this is going to change after do it the first time. Actually, let's make sure NumPy installed. Okay, we got NumPy. Now we need to go import it, obviously. I'm going to move this up by like separating my imports and my from imports for some weird reason. So yeah, we'll make a NumPy array with this label, just an array of 1. And then we're going to do NumPy save that data folder I just created, labels.npy or npy. And so that's the file name and then the object. Okay, so that's good for the labels. The pixels is a little trickier though, because what we need to do is actually reshape the pixels. This will just save us some hassle during the actual training part of things. So first we convert it to an array. We're going to change the type to a float. And then we're going to reshape it to be 1, 50, and 50. Because like I said, we're going from 200 by 200 to 50 by 50. And then we'll do np.save, kind of same drill here, images.npy, npy, and that image. Okay, so we're actually going to run this now. And so if, like me, you've kind of been drawing some rough sketches of letters, this is where you'll actually want to be a little more careful, because now this data is actually going to go into the training set. And it's a little tricky to get rid of bad data right now. So I'm going to be, my handwriting is not perfect, but I feel like that's a good enough letter X. So this is actually going to go into the data. And so I'm just going to stop right here and quit. Okay, so let me just move that out of the way a little bit. I'm going to jump into the shell, import NumPy, and then I'm just going to make sure that this is what we expect. So labels, it's going to be NumPy load and data labels. Okay, now let's look at that. And this is an array with 1 object in it with the character X. So that's perfect. That's exactly what we wanted. This will be images. Let's check that one. Data, images. Okay, that's looking good. Let's actually check the shape of it. So this is 1 by 50 by 50, which is how we set it up. Okay, so that's looking good. Let's go back into here. So we had to do this kind of one by one, because the first time we make the files, and now the second time we're going to like read in the files and then append them, which is kind of a different process. So now from now on though, when we get a letter, we're going to do, instead of making this new array, we're going to do load, just like we did in the shell when we were kind of goofing around. Data labels dot npy. So that loads in that dictionary. And then labels will be, we'll do numpy append the labels we just loaded and this new label. So we're gonna grab that list and add on this new one from the form. And then we can actually keep this here. I'll try to keep these quotes a little more consistent. So basically we just read in the old file, add on the new one, and save it back out. So pixels will be a little similar. We make the image, we can keep that. But we're going to load in the old images by doing the load, data, images. And this is where it might be a little wrong about, but it seems that using this vstack function seemed to be the best way that I could find for combining these arrays. So it's like the append, obviously, but for more of like a multi-dimensional array, which is what we have here. But essentially, it's the same idea where we have the old images and then we just append them on. Fix those quotes, and we save it. Okay, that's good actually. So other than that, I think that's kind of all we really need to do there, because we are we have this built out for adding that message. I'm going to go back to the server, start this up, and let's add some more data. And again, we want to actually do this correctly. You know, don't do any like random squiggles, or else your training won't work out very well. I've got 2 Ks in a row, 3 Ks in a row. It's kind of crazy. Okay. Let me draw one more. K. Oh, another K. That's crazy. This is a good place to take kind of a little deviation from that and add in just one more. This actually isn't part of the app necessarily. But just, this is like a personal preference of mine, is, I mean, although we are choosing a random letter every time, which over time would, you know, lead to a uniform distribution where all the letters have the same number of like data points. I do want to add just like a little script. I'm actually going to just make that folder right now. Scripts where we plot the different counts for the labels we have in our data. And so I'm going to make a new file called data distribution. And I'm going to paste this in because it's, again, pretty boring. Essentially, we have matplot lib. We're going to read in that data file with the labels. And then this just gets the count of how many times we, how many times we drew the letter K, how many times we drew the letter S, and then it plots it. I don't have matplotlib in this virtual environment, so I'm just going to use my like normal Python. Just kind of make things simpler. And I guess that didn't work out in Python 3. And then look at that. So this says we have 5 different classes, so 5 different letters, and we have 8 different data points. So we have K, S, X, Q, and I. As we draw more, we will want this to be really flat, and we will obviously want 26 classes for all 26 letters. So like I said, by just doing this choice, this random.choice of this list, over time, you would approach a uniform distribution of these letters so that each letter has the same amount of training data. What I'm going to do, though, to make this a little quicker, I mean, not quicker necessarily, we still have to train a lot of the data, which will be kind of on you to do all the hard work of drawing a bunch of letters. What I'm going to do is read in this label file, just like we were doing before, and then counting up how many times these labels have occurred. So basically just make an array of the count of 0 using this. So we'll say like, N is 0, O is 0, P is 0, and so on. And then loop through the labels, like our actual label file. And then if the label appears there, just add 1 to it, which gives us a dictionary with each letter and how many times it's occurred in the data. And then I'm just going to sort this by, so we'll give it this key here. So we're sorting by the count rather than just a letter. And then I'm going to choose, actually, I'm not even just going to do choice. I'm just going to choose the last, or like the most infrequent letter that has occurred yet. So that would just be count 0 would be the last one. But this would just be something like this. It'd be like A0. So I actually want to select the A, not just the 0. So it's going to be 0, 0. And I'll keep this here too, because later on, once it's more trained, we will want it random. Just saves you time from loading this in every time. This is a little more resource intensive, I guess. Let's give that a try. And close that thing. And start the app. Add data. Okay, so you see we got an A. This makes sense. We'll probably go in order for the most part. It's going to skip over K because we drew K a bunch of times. But I also like this too because, it's easier for your brain to draw like in the order of the alphabet. Okay, so I'm actually going to speed up this video because it's kind of boring to watch me write letters. But you will want to do this for, quite a bit of letters. And it's kind of up to you how much you want to do. You can kind of say, just draw as many as you feel like. You will want to get at least all 26 written, just so that once we get to the model training, we can train, on all the classes you have. And then depending on like the accuracy you get from your model, you might say, well, I'm going to want to add some more data to my model just so, it gets more accurate. And that's kind of the whole point of this. And then you can also share this, have someone else, write letters, just because everyone, writes a little different. And that's kind of, the end goal here. So anyway, I'm just going to fast forward to this part because it's, pretty boring. All right, so I went ahead and wrote quite a couple different letters added to the training model. Obviously, this isn't, the ideal way to do this. But in many machine learning contexts, data is grabbed, not from one person just writing over and over some letters, but just for this example, that's what we're doing. So I'm going to run that data distribution script again. And you can see I made it so each letter has 10 cases. So there's 26 classes, one for each letter. There's 260 total data points you can see in this plot. We have uniform distribution. Every letter has 10 entries, so to say. So I think that'll be good for now, at least for demonstrating the next phase of everything. Obviously more data would lead to greater accuracy, but that's good for now. So now we're actually ready to start the model training. To do that, we do need to install Tensorflow. And then we can do, we could do this just in Python, but it's generally easier to do this in Jupyter. So I'm going to install Jupyter Lab as well. And so this might actually take a little time to install, so I'll just speed through this. All right, so that finished up. And so at this time, let me just apologize in advance if the sound's a little bad, and probably picking up the sound of my laptop fan. It's not a very powerful laptop, so when we start doing the training, it might kind of get a little noisy, so apologies for that. So let's just start Jupyter Lab. And you can use Jupyter Notebooks or something equivalent to that. They're basically the same. And then once this loads up, I actually wanted to Oh, that's weird. I started in like the scripts folder, so I thought I started in the wrong location. Sorry about that. We actually do want to write this in the scripts folder. At least that's where I want to put it. But we can go back and see our data. Okay, that's good. So in the scripts folder, let's just make a new notebook. And so let's just start with the imports. We know we're going to need numpy. Let's see. Let's do. So we're just going to use Keras for just the higher level API of TensorFlow. And there's a lot of different ways people like to do their imports. We will be making, or at least needing, our bidict, that bidirectional dictionary. I started the right direction. Okay, so let's bring that in. And I'm sure there'll be some other stuff we forget. But for now, oops. Okay, hopefully that loads, which means our installation worked. So I'm just going to grab this encoder and just copy and paste it here. So now we have our encoder. All right, so the next step is to load the data. So we can just start by loading the labels. And so we just go up one directory to the data directory and then into that folder to find that labels.npy. And so if we take a look at that, you can see we have all the characters, so the actual like letters. And so you can see in this labels array, these are just the characters, which is a good thing. You can see we have all our training data. We can look at the shape of this real quick. This has 260, so that's what we were expecting, which is good. But these are just characters. And as I mentioned earlier, these machine learning models, and especially neural networks, don't really work well with like strings and characters as much as they do with numbers, which is why we set up this dictionary to begin with, or this kind of lookup table. So let's actually convert all of these into their respective numbers. And so we'll just do just a simple list comprehension. So grab, for each label in the list of labels, grab the associated value. But I'm also just going to put this back into a numpy array. And then we'll print out the shape. And then we can look at this, and these are all numbers, which is good. So next, we can grab the images. So let's do kind of something similar. Go up to the data folder, into the images.npy. And for the images, we're actually going to convert this to a float 32 and then divide by 255. Right now, the max value, or the range, is from 0 to 255. So by dividing by 255, we scale all those numbers between 0 and 1, which is a good thing to do. So let's print out the shape of that. And awesome. So we have 260 instances, and each of them is 50 by 50. Because remember, this images is a multi-dimensional array. If we just look at one of them, here's one of the images, which doesn't look like much, but that's what our pixels look like. And so we can actually look at one of these a little bit closer with matplotlib. And I don't think I've installed matplotlib yet. When I used it before, I just used it outside my virtual environment, but I'm just going to install this in the virtual environment because we can use the image show function to actually look at what our pictures look like, which is kind of interesting. So while that's installing, I'm going to write out the import matplotlib.pyplot and rerun that. Okay, so what we do is you make a figure first, and then do image show, and I'll just do my first one. remove the grid. And cool, so that's kind of nifty. You can see this is 0 by 50, and that's clearly the letter A. Got a B, and so on. Oops, looks like I skipped C. This is just for fun, just to kind of confirm that your data is coming through as expected, because, you know, once we look at something like this, if we just look at the raw numpy, you know, it's tough to tell. It's like, is this a letter A? I don't know. But now we know that it is, so that's nice to see. I'll just comment that out. Okay, so the next step, and maybe we could have done this up above, but we're going to do expand the dimensions of this. And so now if we look at the shape, you can see it has this extra 1. This will just be important to match up with the input that the neural network is expecting. So yeah, maybe, well, I'll keep it there. So now it's time to split up our data into training and testing samples. So there's a couple different ways to do this, like the actual like Keras model trainer. You could just give it your full test set, or you could give it your full data set. It can do the choosing of training and test for you, but I'm actually going to do it by hand just because it's kind of easier to do some of the validation after. But to do that, I do remember I need this function from sklearn, which we don't have yet, actually. That's the trouble with virtual environments. You forget all the things that you usually like to use. So I'm going to install, and it's actually, sorry, scikit-learn is how the import is, or the install. I'm going to install Seaborn as well, because we might use that in a bit. So while that's installing, I can at least write out the code. So our labels and our images, we are going to use a shuffle function, which kind of takes these two arrays and shuffles them in place. So they get shuffled, but they're still like corresponding, so that, you know, the correct image is pointing to the right label. We'll set our split at 0.75. Our training labels, this is just kind of some of that subsetting. So we'll do that times the split. That looks good. And then our training set for the labels will be, you know, wherever that cutoff was to the end. And I'm just going to copy this because we're going to do the same with our images. Let's just do this way. Okay, let's see. Okay, that installed, that's good. Now, I guess I'll bring in Seaborn right now. Okay, so we have Seaborn and we have our shuffle function. So now we can run this block, which shuffles it. If we look at labels, train shape, and the images train, those correspond, so that's good. Let's delete those. Okay, so now we're actually ready to build out the network. And let me just say real quick that we're really not going to spend too much time tuning it necessarily, because, you know, that's a whole nother, you know, that could be a whole video on its own. This is mostly just kind of putting all the pieces together. So definitely play around with this and try to see what works. But for the most part, I'm just going to kind of throw in some random numbers, you know, just to get this all built out. But we do define our batch size and the epochs. We are going to make a sequential, and then just do kind of the array version of it, where you just pass in all the little pieces. So this is our shape. And remember, this is why we did that on this expand dimensions right here, because we can specify the shape as 50, 50 by 1. which I'm pretty sure is like the color channel. And since we're just doing black and white, there's just that one channel that we're working with. So yeah, we are going to do like a convolutional neural network, which is kind of the best option when it comes to like image recognition or any sort of use case like that, where the data can really be in any one of the columns, if you kind of think of the data set as a table. But yeah, let's just do, like I said, we're just going to piece this together pretty quick. We'll do the ReLU. Then we're going to do the max pooling. Then let's do a dropout. And then let's just repeat this actually. And this time maybe up that. Maybe we don't need. Oh no, we'll keep the dropout, why not? But we do need a flatten. That kind of brings us back into a more like a 1D space. And then we'll do our final layer right here. And so we have to give it the length. And so we can just give it the length of the encoder. And I think we need to add one to this. I'll come back to that if we're wrong. And then because this is like a multi-class classification, softmax is generally the activation function that works best for that. All right, so that worked so far. We might have errors once we actually try running it. We are going to put an early stopping, just because that's, I feel, you don't have to worry so much about the epochs. Choosing the right number, you can just kind of rely on the early stopping. And we want it to stop when the validation accuracy starts to not change, and we'll give it like 2 tries. Set the optimizer to the atom. I feel like that's pretty normal. Okay, now we can do the model compile. And we're going to do sparse categorical cross entropy. And the optimizer will be our optimizer. And we want to track that accuracy. Okay, there's our first issue. This is supposed to be optimizers. Okay, there we go. Okay, now time for the model fit. So now we give it our training X. So those images. Oops, I'm trying to format that better. And then our labels train. Well, the batch size is our batch size variable. Epochs is our epochs, of course. Validation data. So this is just a tuple with our test X and our test Y. And then we need to add in our early stopping that we set up. Okay, so let's see if this starts running, and it does, which is good. And so you can see as this runs through, we have our training accuracy and then our test accuracy. And just like that, it actually stopped after the 4th one because of that early stopping. We didn't get any improvements here. But 90% accuracy, that's not terrible, especially because I did kind of just throw in some numbers here. Like I said, again, didn't want to spend too much time, tweaking this, even though that is kind of the fun part of these kind of problems. But let's just stick with 90%. That's good enough for me, I think. But just in case we are interested, it would be, and we don't want to get too in the weeds with model analysis or anything, but we can generate some of the predictions for our test set. And we do need to do this numpy arg max, just because when you do the prediction, it gives you all the classes. That's how the softmax activation function works. It gives you all the probabilities for all the different options. And then the highest probability would be the actual prediction. So the argmax helps us with that. And so I actually want to put this into a confusion matrix, just so we can kind of see the breakdown of where the classifier is doing well and where it's doing well and where it could use some more like training. So let's bring in the confusion matrix from scikit-learn. Okay, so use a confusion matrix. We'll give it the true values from our test data set and our predicted values. And we can give the labels too, which is just going to be, it's going to occur in that order, which is nice. So we're actually going to do, we need the inverse this time, because we're not doing the letters necessarily, we're doing the actual numbers. So that's what the inverse. This is actually the first time we're using like the bidirectionality of that bidict. Okay, there's our confusion matrix, which is not fun to look at. So that's why we brought in Seaborn. And let's put that in. So let's do Seaborn heat map. Give it the annotation. We'll do the colors blues. Let's show that. Hopefully that works. Okay, that's not bad. Let me change. Let's do figure. Big size 1212 maybe. Okay, cool. So I guess one thing, this would actually be nice. Xtick labels. If we set this to be the list, again, we always have to convert this, which is a little bit annoying. Encoder keys. And I'm going to copy that and do the same with the yticks. And I misspelled that terribly. This will be a little easier to read rather than those numbers. Okay, cool. I guess one thing we're missing that I don't feel like adding right now would be which column is predicted and which one is actual. I forgot which is the default, but it is interesting to see that, right here is M and H. There's an M getting misclassified for an H, or the other way around. Like I said, I forgot which is the axis. Ideally, we want most of the data points right on this diagonal, but this is a quick way to see where, some things are variation, like K and X, that makes sense, It's just this K has like a flat line on the left rather than the X, which is, angled. K and F, well, it kind of makes sense too. F just has two things sticking out of it, so does K. So this would, if you did want to improve the accuracy, add some more data points, these are ones you could focus on, which, is a kind of a good approach, that if, certain ones are misclassified and needs more samples of those, rather than A, which seems to be fine. You can always classify A correctly, at least in this sample. But yeah, that's kind of, like I said, I don't want to go too much into like the model analysis, but just a little fun thing to do. What we do want to do though, this is actually getting back on track, is do model.save. So this is saving our model that we can start to use in our alphabet quiz, right? So let's just save this as letter model, whatever you'd like to name it as. And this takes this model and saves it. Pretty obvious, right? Cool. So now we kind of were really focus on this for a bit, we're actually going to get back into the app, or at least the code for the app, to finish this out. And if you want, just this is where my cursor brought me. You can change this to random now, just to make it a little more fun and, you know, less writing the alphabet straight out. But this is in good shape. At least this add data, this add data post. And so now we need to get to this practice page. So for the practice, kind of similar to the add data, at least the first step is we need to give it a random letter to, you know, ask the user to write. So I'm actually just going to grab that and say this letter is going to be, you know, a random letter from our list. And then we'll do that. Just pass it over just how we did before. So when we open up our practice.html page, you can see we're still kind of behind in terms of the changes we made to that data. You know, we've added the form and all that stuff. So rather than write that from scratch, I'm going to just bring this over. The only change, well, let's not completely erase it. You know, we'll keep these two lines over right there and there, you know, because we need this form. We're going to say check my answer, practice action. We want the letter to go in there. That's good. This action, this will need to change. This needs to go to the practice route, and this will need to be called the practice form. We can keep this, right, uppercase, blank, you know, with the letter. I think we are going to use a message, so we keep that, so that's good. Okay, awesome. So let's open up the JS as well. This will need to change. Let's grab those, you know, so we're not just printing it out. And this is going to submit the practice form. So now this is going to send the pixels and the letter that we prompted the user with, back to the server. So let's go back here. The practice get, that looks good. So now we're here. And so what we need to do is we're going to get the letter from the form. And yeah, so we called it a letter. I think we did the same. Let's just double check that actually. Yeah, so we called it a letter. So that's going to come through the form. This is the letter that we told them to write. So this is like the actual one. And then let's get pixels. It's going to be kind of how we did before. Grab the pixels. And then I guess I could have just copied this. Grab the pixels, split it from a string into an array, reshape this to the right shape. And we actually, I think, need to shape this, add this one, just because we need it to be a single picture that we're going to feed to the model. So that's important. And then we're going to do model is Keras models load model. And so you should see in your file directory the letter model. So that's good, or whatever you decided to name it. We do need to install, or not install, but import Keras. So let's do that. Tensorflow import. Okay, that's good. Once again, probably not the best way to do this to load the model every time. You know, it would be smarter to maybe load the model when it first loads and, you know, pass that around, you know, in the session rather than loading the model every time you make a question. But I didn't really go far enough to add that, but that's a, you know, good thing to keep in mind and maybe add on your own if you'd like. So let's now make the prediction. I'm just going to call this predicted letter. It's going to be that argmax model predict. We're going to predict that image. the x is -1 just kind of tells it how it's going to make that max. So we need that. And then, so this is where the encoder really comes in, because, well, let's just stop there actually, before we get too ahead of ourselves. Let's just print this predicted letter. Yeah, make sure everything's working fine. Yeah, let's do that. Let's see if there's anything else we could do, but something might break, but that's fine. Back to this quiz. So now practice, write uppercase J, so it's just a random letter. Check my answer. Okay, so something broke, that's fine though. Let's see if it printed out. Okay, so it predicted a 10. I'm not sure what a 10 is. Looks like a 10 is a J, so that's good. We drew a J and it predicted a J. That is, I guess, comforting for our model, and those are models somewhat accurate. But hopefully you did notice that it was kind of manual effort. We had to come up here and kind of look to see what does a 10 mean. So this is where the encoder comes in, because we want to map this 10 back to a J. And this is why a normal dictionary, I mean, it could do this if you added some, wrote some functions out for it, but that's what this bydict is doing for us. And I really like using it. So we're going to take this letter, which right now is actually a number, and do encoder.inverse, which now it's kind of flipping that dictionary. And then predicted letter. And we got to add this 0, because if you noticed, it's actually an array. So it's an array with only one thing in it, that letter or number 10. So make sure we just select that 0, that first element, and then take the inverse, which in our case, if it was a 10, this would return a J. So now the next step is to actually compare these. So we can do, let's not do message actually, because we're using message up here. Let's just say correct, like whether they corrected it, or sorry, predicted it correctly or not. So correct will equal yes if the predicted letter equals the letter. So this is the actual letter that we prompted them with. This is the predicted one. And so if we say draw a J and they drew an L, or something wrong, we're relying on our model to predict that correctly. So if our model says, looks like you drew an L, we'll say, well, an L is not a J, therefore, correct is going to be no. I don't need that equals, sorry about that. Great, I think that will work just fine. Okay, so now I'm going to grab this, because what we're going to do is, rather than do like the redirect like we did up here, we're just going to render that page again, but just make sure that we give it the new letter, which now that we've used this letter up here, we can overwrite that value and say, now letter is going to be a new randomly chosen letter. But we're also going to pass correct, which will be that yes or no. So if I go up to our practice page, we copied this over from the add data. That's why we have this message. So it's going to look a little differently now. We're going to say if correct, if that variable exists, then we will do a nested if. So if correct equals yes, then we'll say correct. And then maybe like next question, kind of pointing down to the next one. Otherwise, basically the same thing, except it's going to say incorrect. You know, you could get a little fancy here and do like different styles or something, like maybe red letters if it's wrong. And sorry, that should be end if. Okay, I think this will work fine. And then maybe just for this first get, I can't remember right off the top of my head if this will identify if it's a undefined variable or not. But just to play safe, we'll just say correct equals, you know, a blank string, which is false. So it'll say if correct, and then it'll skip that. So that should work fine. Let's give it a try. Looks like it died on us, so let's restart it. And so you see it kind of takes a little longer to load now because it has to bring in Tensorflow. So let's do practice. And so let's write uppercase G. And it says, taking its time. It says correct. Next question. So awesome. So it, I don't think we have any print statements in the log, but basically it sent that G back to the server. It took my pixels, it predicted my pixels to be a G and said it was correct. Let's try one more. These are kind of tricky. You might think that's an O. Oh no, it's good. Okay. So it says write an uppercase F. Let's write an uppercase A instead. See what that says. So it says incorrect. Very good. So that was the wrong answer. So that worked as expected. You know, if you played with this for a while, you'd probably get some cases where it tells you to draw a letter and you correctly draw it and it doesn't work. And that's just, you know, part of dealing with a model that might not be as accurate as it could be. So definitely play around with that a little bit. But otherwise, that is basically it. You know, like I said, there are some things you could kind of play around with and make it your own, but you can continue adding data to the model. You will have to run this notebook if you want to update the model with the new data. You know, as long as you run this model.save, the app will start to use that model. But yeah, that's it. And thanks for watching.